Hey guys, how are you all? So in this video we are going to discuss about the nucleophilic addition and elimination reaction. Okay, so first thing, the addition of hydrogen cyanide in the aldehyde. So aldehyde and ketone react with hydrogen cyanide to yield the cyanohydrine. Okay, to yield the cyanohydrine. This is your cyanohydrine, right? So therefore it is catalyzed by base and generated cyanide ion being a stronger nucleophile readily add to the carbonyl carbon, so to yield the corresponding cyanohydrine. So I will give the one more example. Look here, if I am taking the CH3 C double bond O hydrogen, so at the time if I am using only HCN, so it became H plus and Cn minus. We all know that, right? This is electron deficient, this is electron rich, so this is going to attack the electron deficient carbon, so this negative charge obstruct the proton, so there is a formation of your cyanohydrine. Okay, this is, we call it as a cyanohydrine. Okay, alcohol and Cn together in the same carbon, so we can say cyanohydrine. Okay, so in this if you are using only HCN, at the time your reaction rate going to be lower. So if you are using the base, okay, so at the time this base, what it do is it going to generate the your nucleophile, so reaction will be faster. Clear? So next we go for the aldehyde, addition of sodium hydrogen sulfide. Okay, addition of sodium hydrogen sulfide. So if I am taking the sodium hydrogen sulfide, so NaHSO3, right, this can be changed into Na plus plus HSO3 minus. Okay, Na plus HSO3 minus. Clear? So if I am taking the CH3 C double bond O and CH3, okay, we have a two part, right? So Na plus and HSO3 minus. So HSO3 minus attack the your electron deficient carbon, so the pi bond will move here, so this negative charge obstruct the your sodium. Okay, so what is the product? CH3 CONA and HSO3 SO3H, then your what is there, your CH3. Okay, so there is a transfer of proton here. Okay, so at the time there is a formation of CH3 CSO3Na. okay, CH3OH. Clear? Right? Okay, so this is bisulfite addition compound, this is crystalline nature. Okay, so here there is a proton transfer reaction. Clear? Right? Okay, next we go for the reaction with Grignard reagent, right? So your addition of Grignard reagent, I discussed with you this reaction in detailed way in previous lesson, alcohol phenyl ether. Go and watch that video. Okay, I explained very beautiful way. Okay, so then we go for the addition of alcohol. Okay, so if I am taking the alcohol, so here there is aldehyde, it's here. Okay, here is the aldehyde. So this aldehyde, can I write it in like this way? C double bond O hydrogen. Okay, so this ROH we can write it as a RO minus H plus. Okay, so this RO minus attack this carbon, electron deficient carbon, the pi bond move here, this obstruct the proton, there is a formation of acetal. Okay, then there is again ROH is there. Okay, so again what it going to happen is here this OH and hydrogen combine together form the your water molecule. This O are going to bond with the air. Okay, so this is acetal. Clear? Next, here there is again there is a formaldehyde react with your ethylene glycol. So again it is formed the ethylene glycol ketone formation. Clear? Next, look here, your nucleophilic attack acetal ketone formation we already discussed in previous slide. Okay, in this addition of ammonia and its derivative. Okay, addition of ammonia and its derivative. So I will take the any one aldehyde. Okay, C double bond O hydrogen is there. What are the derivative it is there? So I have NH2R, I have H2NOH. Okay, then I have NH3, so H2N and hydrogen, then you have hydrogen, right? So H2N, NH2. Then we have phenyl hydrogen, right? Phenyl hydrogen. So phenyl hydrogen, so H2N, NH, C6H5. This is phenyl hydrogen. Then we have 2,4, dinitro phenyl hydrogen. So this is your phenyl hydrogen. In the second position and fourth position there is a NO2. Okay, so next one there is a semi-carbazone. So H2N, NH, C double bond O, NH2. Okay, so this O react with H2 and H2, 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 H2. Your product is forming like this. Okay, all this product here. So here your doubt might be, so this side also NH2 is there, this side also NH2 is there in case of semi-carbazone. So here this is electron withdrawing group. Okay, so due to the presence of electron withdrawing group, this NH2 basic character bit decreases, but in case of this one is more electron rich. Okay, so it can act as a more nucleophilic nature. Okay, so compared to this NH2. Clear? Right. Then we go for the reduction reaction. Okay, so reduction of aldehyde ketone. So if you are reducing the aldehyde, you are able to get the primary alcohol. In case of ketone, okay, we will get the secondary alcohol. Okay, so in case of reduction to hydrocarbon, so we have a two naming reaction, it is there. Okay, so in this there is a Clemmensen reduction, there is a Wolff-Fishner reduction. This is very, very important. Okay, if I am using the Clemmensen or Wolff-Fishner, okay, so in both the cases your C double bond O, which will be converted into CH2. Okay, so I will explain to you. Look here. So here there is a reduction reaction. Okay, so in Clemmensen reduction we are converting zinc amalgam, converting ketone to this carbonyl group into CH2. Okay, so at the time we are using the zinc amalgam and HCl. So will I give you one example for that? So this is your aldehyde. So if it undergo the Clemmensen reduction, your product is ethane. Okay, so if I am taking the benzaldehyde, okay, this also undergo the Wolff-Fishner and Clemmensen reduction. At the time you are going to get the C6H5CHO, right? So you are going to get your toluene. Okay, clear? So you have to apply wherever the reagent is. When we mix with this reagent, your aldehyde ketone, what it become, that is more important. Okay, you should apply it. Okay, so then we go for the oxidation, right? So I will explain this oxidation reaction bit detailed way. Okay, look here. If I am taking the primary alcohol, okay, secondary alcohol, okay, then your tertiary alcohol. Okay, so if I am using the mild oxidizing agent, okay, mild oxidizing reagent. Okay, so at the time it is become a aldehyde, this become your secondary alcohol, become a ketone. Your tertiary alcohol will not undergo the reaction, okay, in presence of mild oxidizing agent. But in case instead I am going to use the strong oxidizing agent, at the time your primary alcohol become a acid. Okay, so your secondary alcohol again it is going to give the ketone only. Okay, but in case if it after the yield of ketone, okay, this aldehyde further if you oxidize, what it going to give? Again it going to give the acid. This ketone give rise to acid, there is no doubt. Okay, but here there is a breaking and oxidation, breaking of molecule first take place, then only your oxidation product. So in case of tertiary alcohol, if you are using the strong oxidizing agent, again there is a breaking of carbon-carbon bond, then there is a formation of acid. We already discussed it. Okay, right. So first we taken the aldehyde. Okay, so aldehyde oxidized to become a your acid. Okay, so here aldehyde differ from ketone, their oxidation reaction. So aldehyde easily get oxidized into carboxylic acid on treatment with common oxidizing agent, that is nitric acid, potassium permanganate and potassium dichromate. So even mild oxidizing agent, mainly the Talens reagent, that is ammoniacal silver nitrate. Your Fellings reagent, Fellings A and B solution is there. That is both are mild oxidizing agents. So ketone generally oxidized under vigorous condition. So strong oxidizing agent at elevated temperature. Strong oxidizing agent and elevated temperature. This is very, very important. Okay, so their oxidation involve carbon oxygen bond cleavage. I already told you. So the acid having the number of carbon atom lesser than the ketone. Okay, so I will explain to this the carbon cleavage in the your ketone. Okay, so I will give you one example. By using that I will explain to you. Okay, so clear. CH3, CH2, C double bond O, CH3. Okay, so I am using the strong oxidizing agent. Okay, strong oxidizing agent. At the time there is a two type of breakages possible. One is here, one is here. If it breakages here, if I keep this CH3 as a dash. Okay, so if it breakages here, so this 2 carbon acid, this 2 carbon acid. But in case of breaking is here, at the time this 1 carbon acid, 3 carbon acid. Okay, if it A breaking, okay, your product is CH3, CH2, COOH. Then one more product is HCOOH. Okay, this is breakage of B. Okay, in case of breakage of A, both are 2 carbon only, so 2 CH3 COH. Are you clear? Right. Next we go for the Talens test. Okay, we go for the Talens test. Look here, there is a mild oxidizing agent, that is on warming aldehyde with freshly prepared ammoniacal silver nitrate. I already told you the Talens reagent is ammoniacal silver nitrate. A bright silver mirror is produced due to the formation of silver metal. Okay, so aldehydes are oxidized to corresponding carboxylate ion. So the reaction occurs in alkaline medium. So alkaline medium, then this is your silver, okay, reagent. So we will get the carboxylate and the silver mirror. Okay, this is the silver mirror. If it silver mirror is there, then your compound is aldehyde. Okay, when it comes to the Fellings test, Fellings reagent test comprises of two solutions. So Fellings solution A, Fellings solution B. The Fellings solution A is aqueous copper sulfate. The Fellings solution B is alkaline sodium potassium tartrate. So Fellings solution A is aqueous copper sulfate. Fellings solution B is sodium potassium tartrate or Rosselló salt. Okay, this is more important. These two solutions mixed in the equal amount before the test on heating with aldehyde. So Fellings reagent, so reddish brown precipitate. This is very, very important. Reddish brown precipitate is obtained. Okay, so this is your reddish brown precipitate. This is your carboxylate anion. So this is your the two reagent ammoniacal Fellings solution A is copper sulfate, aqueous copper sulfate. Fellings solution B is sodium potassium tartrate. Clear? So we will go for the next. Here there is a question which is given here, so I will explain to you. Okay, so after this holoform reaction, okay, I will explain it in a very simple way before I explain this theory. Okay, if there is a CH3 C double bond O, or if there is a CH3 CHOH, if two group, if it present in any molecule, it undergo the holoform reaction. Very, very important. Many times asked in the JEE as well as NEET questions. Okay, even in your board exam, right? So if there is a CH3 C double bond, this is methyl ketone. If there is a CH3 CHOH, so it undergo the holoform reaction, right? So aldehyde ketone having at least one methyl group linked with carbonyl carbon. So this we call it as a methyl ketone. This is methyl ketone. Okay, then our oxidized sodium hypohalide to your sodium salt of corresponding carboxylic acid having the carbon lesser than that of your carbonyl carbon. Okay, so the methyl group is converted into holoform. This oxidation does not affect the carbon-carbon double bond if present in the molecule. Okay, if it carbon-carbon double bond is there, okay, it will not going to affect by this reaction. So holoform reaction, sodium hypoiodide is also used for the detection of CH3CO, CH3CHOH group. Okay, which produce the CH3C double bond on oxidation. Right. Next we go for the question which is we have to discuss it. An organic compound A, the molecular formula is C8H8O. C8, H8O, this is acetophenone, forms an red-orange precipitate, orange-red precipitate, okay, so with 2,4 dinitrophenylhydrazine, the reagent give yellow precipitate on heating with iodine, so there is a formation of iodoform. Then presence of sodium hydroxide, neither reduce the tolerance and Felling's reagent, so it does not having the aldehyde group, okay. Then on drastic oxidation of chromic acid, it gives rise to carboxylic acid having molecular formula C7H6O. It is probably benzoic acid. Then identify the compound, right? So first one is the precipitate is when it reacts with 2,4 dinitro give rise to yellow precipitate, right? So this is your DNP, 2,4 DNP, okay, so 2,4 phenylhydrazine. So this H2, this O, it is converted into H2O, okay, so this is your derivative, clear? Next reaction, look here. So here it is the next reaction, as I told you already. So if it undergo the Aldehyde reaction, so it is because it has the methyl ketone, right? It will undergo the Aldehyde reaction. There is a formation of chloroform. So it react with H2CrO4. It give rise to your benzoic acid. Understand? Right. So reaction due to alpha hydrogen. See, look here. Any aldehyde or ketone, presence of alpha hydrogen undergo the aldol condensation. Okay. If it absence of any aldehyde and ketone, absence of alpha hydrogen, it undergo the Cannizzaro reaction. Okay, Cannizzaro reaction we call it as a disproportionation reaction. I will tell you why it is. Clear? Okay, right. So here why it is called it as aldol condensation, why it is aldol, okay, this thing I will explain to you, okay, clear? So first thing first, here the first step is there is a carbanion formation, okay, I will tell you how. CH3 CHO, when it react with your base, at the time this base is abstract this acidic proton, because this is electron withdrawing group, so acidity of proton get increases, okay. So at the time there is a formation of carbanion, okay, there is a formation of carbanion. This carbanion, okay, this carbanion attack your carbonyl carbon, okay, attack the carbonyl carbocation, this become a minus. Then here there is a protonation take place, so there is a protonation, at the time it become a OH, right? Your product is aldehyde as well as your alcohol, so this we call it as a aldol, okay. So this any reaction, okay, if there is a elimination of water is take place or dehydration take place, we can say the condensation reaction. So this is condensation, so this is aldol. After that there is a condensation, at the time there is a formation of enol, clear? Right. So the second reaction also same reaction, okay. So here your alpha hydrogen contained your carbonyl compound, both aldehyde ketone which has the alpha hydrogen, so both are same only, right? So this is we call it as a purely aldol condensation. But in case if I am taking the one molecule is aldehyde, one more molecule is your benzaldehyde, okay, at the time, so two different molecule, right? This we call it as a crossed aldol condensation, So here also I will explain this two steps of this ketone which is undergo the aldol condensation. Look here, so your ketone, okay, this OH minus, it abstract the proton, it become a CH2 minus, C double bond O, CH3. So it attack the your ketone, this CH2 minus attack the carbon, so this become a minus, okay, this get protonated, so your ketol is formed, okay, this is ketone, this is alcohol, ketol is formed, so this is OH. So here in which carbon the proton is more acidic, this carbon only proton is acidic, so from this one hydrogen, so here from OH, okay, so from this one hydrogen, here from OH, if I remove this, so the double bond will be formed here, right? So this is your enol formation, okay, clear? Right. Next we go for the another reaction. Okay, look here, the first one reaction, this is crossed aldol condensation, one more, two aldehydes are different, but both having the alpha hydrogen. Okay, so here in case we get the 4 product, I will tell you how. Okay, so look here, so both molecule will generate the carbanion, right? So both molecule will generate the carbanion. The first molecule will generate the carbanion like this. Okay, the second molecule will generate the carbanion like this. Okay, right? So I took the 2 carbanion. Okay, so here there is a 2 molecule having the carbonyl group, right? So CH3, CH2, C double bond O, hydrogen. Clear? Right. So if it attack this carbon at the time, one product. Okay, to attack this carbon, we'll get the one product. Again this carbanion attack the second molecule, so second product. Okay, the same way I have to took the 2 more molecule. So again CH3, C double bond hydrogen. Here the carbanion from the different molecule. Okay, so again your CH3, this is CH2, this is CH3. So here hydrogen is there. If it attack again this carbon. Okay, so look here, ma. In this, one more thing I want to explain. This carbonyl, this your carbanion molecule and as well as your carbonyl carbon molecule, both are same, right? So this is self aldol condensation product. So this 2 also a self condensation product, but this 2, 1 and 2, this is crossed aldol product. Clear? Right. So we go for next. So look here, so this is your benzaldehyde. So this is our alpha carbon. So this carbon not having the any hydrogen. Okay, so this is absence of alpha hydrogen. So this having the alpha hydrogen. Okay, this having the alpha hydrogen. In this case, there is a formation of carbanion from this your acetophenone. Okay, C6 and H5. This going to attack this carbon. So there is a formation of aldol. After that, there is a removal of water. We will get the 1,3 diphenyl prop 2 in 1 1. Okay. Next we will go for the condenser reaction. Look here, your condenser reaction. So this not having the any alpha hydrogen, right? So why it is called as a disproportionation reaction is, if I am taking the A molecule, this A molecule, it has to undergo the oxidation as well as reduction. Okay, so one element, if you might have studied in the redox reaction at the time, the same molecule which undergo the oxidation as well as reduction, so that we call it as a disproportionation reaction. So this molecule, the same molecule, okay, so one is undergo the oxidation, so acid, one is undergo the reduction, so this is your alcohol. Okay, again benzaldehyde, if it undergo the oxidation, benzoic acid, if it undergo the reduction, alcohol. Okay, this is disproportionation reaction. Understood? So next one, as I told you already, if it benzene is bonded with the electron withdrawing group, at the time your ortho and para position, electron density decreases, right? So your meta position only, the electron density is more. So that is the reason why when you do the nitration at the time, you are getting the nitro product. Okay, nitro product on the meta position. Okay, so arrange the following molecule increasing order of their reactivity. Okay, so I will write one by one. So your first molecule is ethanol, right? So this is your ethanol. Then your propanol, right? So CH3, CH2, C double bond O, hydrogen, or propanol. Then we have propanone, then we have butanone. Okay, then we have butanone. Okay, this is your butanone. Look here, this is 2 aldehyde, this is 2 ketone. So obviously your aldehyde is more reactive than ketone. Okay, so in case this is less bulkier compared to CH3, CH2. So your first molecule 1, 2, 3, 4. Okay, your first molecule is more reactive than second. So here also, so both sides there is a bulky group is there. Your third molecule is more reactive compared to your fourth molecule, because if you compare CH3 and CH3 CH2, this is more bulkier compared to your ethyl molecule is more bulkier compared to your methyl molecule. That is the reason why your third molecule is more reactive compared to your fourth molecule. Okay, then we go for the arrange the reaction. Again okay, the nucleophilic addition reaction only, right? I will write all the molecule formula, then we discuss. Okay, so first I will write the acetophenone. Okay, this is your acetophenone, right? So then we have your benzaldehyde. Okay, then we have benzaldehyde. Then para-tolualdehyde means in the para position there is a CH3. Okay, this is your second molecule. Then this is your third molecule. Okay, then this is your third molecule. So here there is a CH3, CH. Okay, so in order to your nucleophile in order to attack your electron deficient carbon, the carbon should be more deficient. Okay, so in case if you are taking the ketone, so there is a electron releasing group is there, but if in case of aldehyde there is no electron releasing group. First, this thing you have to understand. So your ketone going to be least reactive. If I am taking the 1, 2, 3, fourth molecule, your least reactive is fourth one. Okay, your least reactive is fourth one, right? So because this is ketone. Okay, then we have a aldehyde. Okay, one molecule which has NO2, in another molecule we have a CH3. Okay, so here the electron will move towards the your NO2 at the time your in your carbonyl compound the electron density get decreases, but in case here this is electron releasing group, it push the electron towards the ring. At the time the electron density here get increases. Okay, so due to the electron density increase over the CHO, at the time the carbon is not that much electron deficient, so this is less reactive. Okay, so your third molecule is more reactive. If you are comparing the first and second molecule, the first molecule, okay, so electron density neither get increases nor decreases, so your first molecule. Then your second molecule is, so if you are comparing the reactivity, your second molecule only more compare with your ketone, right? So your CH3 bonded one. Okay, then we have number 1, then number 3 is more reactive. Clear? Understand? Right. So next we have to write the product of this reaction. Okay, I will write one by one. Okay, the first one is, so as I told you already, so this is your C double bond O, this is most basic proton, so this 2 proton, this, okay, react at the time there is a formation of double bond NaOH. Okay, then here we have, right, so this 2 hydrogen, this oxygen get react at the time your site, so NH, then your 2,4 dinitro phenylates. Okay, this is the your second product. When it come to your third product is your aldehyde react with semicarbazone, right? So in this I want to tell you one thing, as I told you already, so this is more nucleophilic nature, nearby only NH is there, but this is less nucleophilic nature because the electron density decreases because of presence of this electron withdrawing group C double bond O. Okay, so at the time this H2 and this oxygen react, right? So your product is RCH double bond CH double bond N, NH, okay, C double bond O, NH2. Clear? Then we go for the your acetophenone, right? So this is your acetophenone, double bond O, CH3. So this O and this hydrogen get react. So then there is a double bond N, CH2, CH3. Clear? This is your product. Then we are going to discuss the uses of your aldehyde ketone. Okay, so first one, look here, the chemical industry, aldehyde and ketones are used as a solvent. Okay, the first one is solvent, the starting material for the synthesis of other product. Okay, so formaldehyde, well known for formalin, it is used to preserve the biological specimen. This is the second one. Okay, then prepare the backlight, formaldehyde used to prepare the backlight, third one. Then urea formaldehyde, glues other polymeric product of aldehyde used primarily for the starting material for the manufacturing of acetic acid and ethyl acetate. Okay, vinyl acetate and polymer and drugs. Okay, benzaldehyde is used for the perfume and dye industry. So whatever the perfume you are using, that is your benzaldehyde. Then your acetone and ethyl methyl ketone, common industrial solvent. Many aldehyde and ketone, butyraldehyde, vanillin, acetophenone, camphor, okay, are all known for their odor. okay, known for their odor. Clear, right? Okay, so any doubt you can comment it. Okay, so for your doubt I can make the separate video. Okay, so do comment in the comment section. Okay, thank you all. Do well in exam. Thank you.